My father arrived in Ellis Island without knowing a word of English, but with a series of great public schools, the Bronx High School of Science, the City College of New York, he became a professor at the University of Illinois. That's where my path began, at Uni High in Urbana, Illinois, degrees in physics and mathematics at Cornell, a PhD in physics at the University of California, Santa Barbara, and a professorship in physics at the University of Texas in Austin. Not long after I arrived, I began preparing science and mathematics teachers. At first, there was a handful, then dozens, and then hundreds. Our team of master teachers and faculty and staff worked to prepare the best teachers we could. Through a series of happy accidents, it became possible to have national replication of the program You Teach we had created, and now the number of teachers we were preparing grew from the hundreds to the thousands, coming from all parts of the United States. But there were voices calling this into question. They said public education is broken. In the last 3 decades, per pupil spending on K-12 education has doubled. Achievement scores have been flat. We must approach education willing to blow up what doesn't work or gets in the way. And I wondered, are things really that bad? I turned to data because my background as a physicist pushed me that way, and I rapidly got one lesson more than any other, which is that nothing makes sense in education except in the light of poverty. Let's have a first example from my home state of Texas. Take every high school in Texas and plot the percentage of graduates with college-ready SAT or ACT scores. Now, if you just take a look at them, plop them down on a chart, it doesn't make any sense. But if you spread them out, spread every school in the state out according to the poverty concentration, then there is a pattern. You put the better off students on the left and the low-income students on the right, and you see that there's a very strong relationship for every high school in the state between poverty concentration and college readiness. Now, this is not always accepted. Some say that poverty presents real challenges, but even in the toughest of neighborhoods and circumstances, children excel when the right adults are doing the right things for them. There's a problem with that statement, however. Just take a look at this chart. Over on the right-hand side, where poverty is the most concentrated, there simply are no schools that are getting almost all of the students ready for college. Now, you may say, what about the charter schools? Aren't they doing a great job? Let's have a look at them. Let's highlight them. Most Texas charter schools are rescue schools, simply trying to have students graduate in some fashion from high school. There is a small number of them doing as well as any public schools do with highly concentrated poverty, getting students ready for college. But the overall lesson is that no Texas schools with highly concentrated poverty reach a high academic level with most students, not even the charters. Internationally, we know that America's competitive position is at risk, that among 30 developed countries, the United States is ranked 25th in math and 21st in science. Well, one has to admit it's true. The data come from PISA, the Program for International Student Assessment, and here are some of the data. These are from 2006, showing how the United States ranked in mathematics measured amongst 15-year-olds and compared with countries from Western Europe and Asia. We are indeed near the bottom. But there's another way to look at it, and this other way comes by breaking countries out according to the levels of child poverty after taxes and transfers. These are data assembled by UNICEF. PISA also broke U.S. schools out according to the level of poverty in the U.S. schools, and if you take a look at the top quintile, those were 0 to 10% of United States students are eligible for free lunch. Those schools are doing better than Finland. The next quintile, 10 to 25% of the students are getting free lunch, are compared well with the Netherlands and Germany. Our middle group is actually now near the bottom of Western Europe, but we have 2 quintiles to go, and it's those schools with the highest fractions of poverty that drag the U.S. averages down. So the lesson here is that when broken out by poverty level, U.S. schools compare well with the other countries where sensible comparison can be made. Still, what about the flatlining scores in the United States? Let's turn to the National Assessment of Educational Progress, the nation's report card, or NAEP. The farthest up one can follow scores with a fairly high density of data over time is in 8th grade mathematics. Let's have a look at this. In this chart, every bubble is a state. For example, over here is California, and here is Tennessee. The colors indicate poverty concentration in the state, the fraction of students eligible for free and reduced lunch. The size of each bubble is the total number of students being tested. On the horizontal axis are mathematics scores for better off students not eligible for free and reduced lunch. On the vertical axis are the scores for the low-income students, those who are eligible for free and reduced lunch. Let's turn time on and run it from 2000 till the present to see how the scores are flatlining. If they're flatlining, all the states stay where they are. If they move to the right, that means that better off students are getting better. If they move up, that means low-income students are getting better. And guess what? Everybody's getting better, even that little jurisdiction down at the lower left. Well, what is that jurisdiction? It is the District of Columbia. Let's look at some other states. Here's California. Here is North Carolina, Ohio, Kansas, New Jersey. Texas has the highest scores for low-income students, and the highest scores for better-off students come from Massachusetts. So since the scores have been going up, what's the source of the story that costs are doubling and scores are flatlining? There is a possible explanation for it, which comes from the next chart. I'll show the same mathematics scores, but now on the vertical axis, I'm going to put the cost per pupil in constant $2009 for each jurisdiction. So at the very bottom is Utah in terms of cost. Horizontal axis is showing low-income math scores. There's Idaho. Texas is sort of in the middle, at least for 2000. The colors indicate teacher bargaining status. The blue states there's no teacher collective bargaining. So now time sets off, and the states move to the right. We know that because scores are getting better and getting higher, but some of the states are also rising in cost. In particular, there are three that really soar above all of the rest in cost per pupil, heading up above $16,000. They are New York, New Jersey, and the District of Columbia. Down at the bottom, Utah, Idaho, and Texas has held remarkably constant. So these charts turn conventional wisdom on its head. They show that scores of well-off and low-income students have risen in almost every state since 2000. There were large rises in cost, but those mainly took place in New York, New Jersey, and the District of Columbia. Could it be that the stories about flatlining scores and rising costs come from those particular places where the media and policymakers are concentrated? So one final thought. Next time you hear that our public schools are broken and have to be blown up, please don't believe it. Schools have been improving. Teachers have been working very hard, and the remaining problems, which are still severe, are mainly due to poverty, which the schools cannot cure on their own. Public schools have made us great. Be proud. Aim higher.